test, time for your test. No peeking, no cheating, no nothing.
Newton's first law. An object at rest tends to stay at blank.
Newton's first law. An object at rest tends to stay at rest. Perfect. No cheating! Eyes on your own paper. You have 20 minutes left. Where was I?
If two objects are traveling with the same acceleration, but one object has a greater mass than the other, which has the greater force? Newton's second law of motion states that force equals the product of mass times acceleration. These two objects are traveling at the acceleration of gravity, which is negative 9.8 meters per second squared. Exhibit A has a greater mass than Exhibit B. If these two objects were to be dropped into these cups of water, the one with greater mass would have a greater force and therefore would create a bigger splash.
If someone is driving and they are not buckled, and the car hits something, what happens?
No talking!
As you can see, an object in motion tends to stay in motion. Because Barbie here was not buckled up, she stayed in motion when the car came to a stop. And because of that, she now has a concussion. So always buckle up.
If you want to change the force of an object without changing its mass, how would you do it?
How are you still on this question? You've been on it for 20 minutes.
If you want to change the force of an object without changing its mass, you must change its acceleration. This simulation will demonstrate that. In comparison, with the same simulation, watch as we change the acceleration. As you can see with the simulation, a greater acceleration equaled a greater force, and with less acceleration, there was a lesser amount of force.
Mr. McElroy?
Are you done?
Yes.
Go back to your seat.
Oh, God.
Yes. These questions are perfect. Number 3. Each action has an equal and opposite reaction. Wow, I'm great at my job. Third law is that each action has an equal and opposite reaction. When I pull this slingshot back, force is stored up in terms of tension. When that tension is released, the opposite reaction would be to send it forward, and then it still has force left, so it will come back again. Thanks, Newton.
Much later.
Alright, class. Any other questions on the test? You.
Number 6.
Number 6. That was the easiest one. Anywho's it. Number 6 was easy. It deals with Newton's third law, that every force has an equal and opposite reaction. So the question deals with, if you exert a force on an object, that object will exert an equal and opposite force. Dear Ryan. As I was saying, as you just witnessed, I pushed off from this wall in my $500 frictionless chair from Haynes, and I exerted the force on this wall, which exerted a force back at me, propelling me that away.
Oh. I don't get it.
What did you say?
C, right? Okay.
First law. An object at rest tends to stay at rest.
Oh, no.
Now in comparison, with the same simulation, watch as we change the acceleration.
I want to do it later.
Can we redo that?
greater mass would have a greater force and therefore would create a bigger splash.
That's a blooper.